of the GEO community, having been involved with GEO since the very start. He is from United States Geological Survey, is a director of the FGDC, the Federal Geospatial Data Committee of the United States. So Ivan, please, floor is yours.
Thank you, Gilberto, and good afternoon, everyone. And on behalf of my co-chairs, Max Craglia and Stefano Nativi from JRC, providing you this presentation this afternoon. Also want to recognize the GEOS Evolve team. Some of those folks are actually in the room today as well. So on behalf of the entire team, I'm going to kind of quickly walk you through some of the activities of GEOS Evolve. I would say today GEO and GEOS are moving through another transition. We have a new director that came on board last summer, bringing some fresh ideas. In addition, we're in the throes of developing a new work program that will be provided to the plenary in this upcoming meeting in November. In addition, we have a ministerial meeting coming up in November as well, which typically provides the member countries and participating organizations an opportunity to recommit themselves to the GEO processes and also to the support of GEOS as a global Earth observation system of systems. So GEOS Evolve is an initiative that's part of the work program. It has a team of experts as well as a secretariat that takes the opportunity to evaluate new technologies, new events that have come about, new data sources. And it's been pretty interesting over the past couple of days to observe some of the current changes on the landscape with the provision of data cubes and cloud, and now we're even talking about the fog. For those of you familiar with some of those IT activities that are currently coming into play, there needs to have some sort of a check and balances as we think about the architecture of GEOS and what should be included and what should not. So I'm just going to quickly talk a little bit about the background, which I just did, a little bit about some of the priority actions, pretty much where we've been, where we are today, and then some of the next steps in the 15 minutes that I have. Just real quickly, we felt, or the GEO community felt, that there was a need for GEOS Evolve as an opportunity to evaluate and take on board a lot of new activities that developments that we've seen in our community. As I stated earlier, this industry has grown tremendously over the past 10 years. It's now a multi-billion-dollar industry that's not only impacting the academic community, but also private sector and many governments throughout the world. And it's becoming ubiquitous in everything that we do. So it's not only a great tool for science and research, but also it's a very practical tool for everyday citizens. So GEO has a pretty broad mandate in terms of responding to all those users. And I think I made a comment yesterday about the need to engage those users as we think about what requirements we're trying to address as part of the GEOS enterprise. The other point here is that as part of the strategic plan that was adopted a couple of years ago, I can't believe we're already 3 years into the plan, that the GEOS Evolve was adopted as an initiative to provide those checks and balances. Just a couple key points here. Again, our blood process here is that we're really looking to make sure this is a user-driven GEOS. And we want to be able to extend that audience. And I don't think we really have to work hard to do that. It's such a fantastic capability that we're starting to see a lot of interest in folks wanting to take advantage of the capabilities of being shared by the governments. And that's one of the key drivers behind GEO. It's a voluntary construct that allows us to share not only data, but also information and knowledge. And that's why we're very excited about the development of the Knowledge Hub and making that part of the enterprise. I think that's one of those next steps that we've heard the last couple of days. While the data is great, we need to move that data to information and on to knowledge. So I think we're pretty much in step with the thinking that we've heard from the director. We really also want to provide additional focus on access and use. And we've heard that from a lot of speakers over the last couple of days. having ability to access information is great, and discovered information is great, but we also want to have usable and actionable information as well. So for us, we believe that we need to evolve and continue to evolve the current system of systems to meet that goal. You who shared some of this information with you yesterday, I talked about the work packages here. I won't go into details here, but the takeaway here is that it's a pretty comprehensive group of folks that worked on 5 different work packages as part of the work program. Because of the breadth of what's required with GEOS, you can see a number of some of the players that are involved. And I was also pleased that as part of my everyday job is to promote the use of standards and interoperability. So I'm definitely one of the champions there to help push that and see the value in that. And to standards where it makes sense, as we like to say. It's not standards across everything, but standards where it makes sense. And I think that's very important as we think about a system of systems and how we want to interoperate with each other. One of the things that this particular workshop is doing is building on the last couple of workshops we had over the last couple of years, which we've been very pleased with, led by the Secretariat, who had organized the last 2 workshops, focused primarily on data before, and now we're moving also to the spheres of data and technology, recognizing that they're not interchangeable, but they're so closely related. So it's hard to deter from those 2. The other is not only engaging users but decision makers. For those of us who work in governments, it's important for us to be able to make the business case for why we're doing what we're doing, and for what problems we can help them solve. And that's something that GEO and GEOS has been very effective for us over the last several years. But one of the things we also wanted to improve upon is data management and the use of interoperability standards. And not only promoting those, but also strongly encouraging folks in showing demonstrations and identifying use cases where you can show the value and also the value of data management. One of the requirements, I would say, as being part of the GEO community is to adhere to the architectural principles that have been put in place, but also the data management principles and data sharing principles. There's 3 sets of principles that are critical. And for those of us in this business, would probably recognize those as good best practices anyway. So most of us are probably doing those as part of our everyday work. And then there's also been a strong emphasis on not only the use cases, but having a stronger working relationship with the flagships. We heard from 5 or 6 of those yesterday. And one of the key questions that we asked them, well, how are you interacting or sharing your information and data with the current infrastructure? And there was sort of a lukewarm response. So I think there's some hand-holding that needs to occur and some assistance that needs to occur to help them understand the value and having that 2-way conversation on how we share data, but also how we share capabilities across the various platforms. And platforms are that key construct today in how we share information. Here's just the conceptual architecture that we have developed. I won't walk through all of this. Again, you shared this with the audience yesterday. It is complex because it is complex. There are a number of moving parts. There are a number of components that are involved in this architecture, but they all have relevancy, and they're all very critical to the overarching goal of having a system of systems. But we have seen, and at least I have observed the last 10 years, a growth. 10 years ago, we were talking about data cubes and just a cloud on the fringe, and really platforms were being introduced, and now it's part of our everyday vocabulary. So things are changing, and we also are moving more towards a regional construct. GEO, as a governing body, had decided that at this last plenary that they wanted to establish regional GEOs, primarily because we felt it was important to focus on those particular users in those regions, because those regions had a lot of commonalities. Those being in Americas, Afro-GEOS, Asia Pacific as well. So as you can see, that's now been included, and we expect that upon approval of the plenary this November, that the Knowledge Hub will be part of this architecture as well. Not to get too deep into architectural concepts and discussions, but here, this slide sort of depicts some of the considerations that we have been exploring. This is the slide and some thoughts that Stefano has put forward as option model, which is a globally centralized system of systems. It's somewhat what we've been pursuing over the last several years. We're now considering the mesh model and also the silos model. I will say that of the three, we believe that the model, and that gives us a couple of advantages. It ensures interoperability where the standards are being implemented, but also it supports the sharing principles that have been agreed upon as part of the GEO strategic plan. So that's where we are today in terms of the architectural concepts. And again, this is conceptual, and we'll continue to pursue those constructs that make sense as we continue to evaluate those contributions being made and also being promoted by the GEO community. This slide sort of shows where we are today. Again, I think you shared this with us yesterday, and the takeaway here is that earlier years we had developed what we call the GCI, the geospatial infrastructure that really consisted of a number of registries and wikis and things of that ilk, which is kind of old technology, as we know, clearinghouses, old technology. And then we start moving more towards the platform construct, where we're now looking at how these things interrelate, but also how they support each other. And the other thing, as we think about this current architecture and technologies that we're utilizing, what's currently missing, and where are the gaps, and what do we need to evaluate to be able to bring those things to the forefront. So in terms of next steps, as I mentioned earlier, and I talked about transition, we will be transitioning to a new, there's a proposal to transition to a new operating structure within the work program. The GEOS Evolve team has reviewed those proposals, and I think we are in alignment. We do have some comments we'd like to provide to the document in terms of how we believe things should operate. It's really focused on really simplifying a lot of the content that we have in the work program and really taking advantage of those foundational tasks that are going to be supporting the overarching goals of GEOS. So we will be aligning our work under the new task structure and the new work program, and we're looking forward to starting to exercise that. As part of this transition to the new structure, we believe that we will continue to advance the evolution of the geospatial platform and its architecture. This will be based on our analysis of evolving technologies and the new landscape. So many of those things we've heard about the last couple of days and we'll continue to hear tomorrow. And also to be able to recognize and identify those changing patterns of production and use of Earth observation products and services. So some pretty cool tools today in terms of how we're using cubes, but also some of the other advancements in Earth observations. And we need to be able to do that in a way that's going to support those user requirements. And what does that look like? Especially those that are going to be suggested and expressed by the GEO flagships and the regional GEOs and their initiatives as we move out on that new governance structure. So in terms of main actions, we'll continue to design the implementation of the architecture, develop new and test new platform functionalities as a group, and engage the geospatial community. Again, following the mantra of those three objectives of advocating, engaging, and delivering, which is very important, the solutions that our users need. And part of that process will continue to develop a documentation and training that will allow, provide materials for those new components so others can repurpose that information and those findings. And more importantly, we want to make sure that we ensure synergy and interoperability of our regional GEO initiatives because we believe there's a lot of value in doing that and sharing best practices and also our experiences. So with that, I thank you for your attention and look forward to any questions you may have.
Thank you, Ivan. We would like to remind you that you can send your questions through Slido. A number of questions have already been sent, and you can also promote questions by going the like button, the famous like button. Now, this morning we heard from Gunther Landgraf from ESA about the concept of thematic exploitation platforms. Now we're going to see one of these in practice by TerraDUI, and Pedro Gonçalves, who from TerraDUI has been a major expert and a major contributor to the ESA thematic exploitation platform. So many of the platforms are based on knowledge and technologies that developed by TerraDUI. So today, Pedro is going to talk about geohazards. Pedro, the floor is yours.
Thank you very much, Gilberto, and thank you all for inviting us here. So today we'll be, so this is the pilot number 3 in terms of example of the geohazards thematic exploitation platform. And how can we contribute to the knowledge that I can contribute to GEOs? As Gunther mentioned this morning, the thematic exploitation platforms are initially R&D activities sponsored by ESA in a given moment to create an ecosystem of interconnected thematic exploitation platforms. So the idea was that users would access a work environment where they would find all the data and the resources, opposed as downloading and replicating the data at home. So this was quite innovating when they started. And the fundamental principle was really to move the user to where the data and the tools were. So they launched several initiatives in terms of coastal, forestry, geohazards, the hydrology, polar, urban, and food security, as Gunther showed us this morning. The geohazard ones was really a specific one in the sense that was already designed in the context coming out from initiatives from GEO. It was coming from the Geohazard Supersite Initiative, the GSNCL. It was coming also from the GEO's Disaster Working Group. So we had an already established community used to collaborate and was really user-driven model for partnership and community building. It started with a big international forum in Santorini in 2012 with the main organizations covering really the geohazards domain, and this was organized by ESA and GEO. And so the platform, the idea of the geohazard exploitation platform was really a platform already based on virtualization and federation of Earth observation data that would provide services and support to the geohazards community. Here we wanted to really focus in being able to do on-demand and systematic processing services. So this was really having intensive cloud computing power and managing multi-tenant resources where we could share the capability from the different users. From the start, we were designing for access to the Copernicus Sentinel repositories and also all the more historical data, the terabytes of EO data archives that ESA has in terms of ERS, Envisat, and other missions that we have access under the SAILS Working Group of Disasters and the Supersites agreements. Our typical user is it's an expert. So they don't want simple things. They have skills in Earth observation. They know how to process, to analyze, to validate and integrate data. But they really want is to have a fast way to design and to produce disaster response management products for their decision makers, the end users. The end users of this information are not intended to be the direct users of the platform. They can access the platform just to visualize the products, but they are not really the ones that are actually doing the actual processing. And we were designing the platform with 3 main scenarios here. Data exploitation, that an expert run already a processing service that is available there. An expert wants to develop a new service, so it goes to a new service, some application, some code of his own that wants to create a processing chain, and also a new product development that with those processing chains, they are able to generate and systematically create a new information layer for their own community. And so we started in 2015, and immediately we were having the logic of an early adopter. So immediately we were having users that were already evaluating and helping us to build. And so from the last 3 years, we open now into an open and stable service in the JEP pre-operation services. So getting out of under the umbrella of ESA and starting to find out the sustainability mechanisms from other applications. We have an enriched service portfolio, so there are really more than 25 on-demand services using optical and SAR data. These are really complex services that you cannot script around. They might produce full resolution or change detection imagery really to respond to emergency. And we have also systematic services that are from specific dedicated areas. Find this on SoBlue, Creodias, and ONDEF, for example. How do we use this? We use open source software developed in Europe is Open Nebula. It might be a concurrent of OpenStack, the European one, and we are able to do the continuous integration and deployment environment, automatically packaging for the production environment. We have improved the production center and give
And this year, we will start a new project called Brazilian Earth Observation Data Cube Project to focus on building the Brazilian Earth Observation Data Cubes. This is the Sensing Project team, led by Gilberto Câmara. All software and methods, software tools and methods that we develop in this project are available, are open source, and are available on GitHub. All the maps, land use and cover maps, change maps that we produce in this project are also available in the Pangaea. So you can access these data sets there. As I said, the seeds package, we developed a package. This package called seeds is available in GitHub. It provides a lot of methods that I presented here, using existing R packages such as Coroning R package that provides self-organized maps method, and other existing R packages to handle forests and deep learning methods, so we can access them. In the Sensing project, you use AWS to create land use and cover maps using the seeds R package. So in this project, we use the AWS using the cloud credit for research, and we use two services. We use the Amazon S3 to store the buckets with modes project files, as you can see here in this picture. And we use the Amazon EC2 service to run a RStudio server with seeds package to classify the time series extracted from these buckets. So we use this. This is an example of an R package. And this R package using seeds. Here we load the samples. After that, we can select bands with these samples. After that, we train our classifier, in this case, SVM classifier, using these samples, and build a classification model. We select the coverage that we want to classify, in this case, and after that, we classify this coverage and return a raster. So it's simple like that to create a classification, land use and cover classification using seeds. This part of the script is related to another package called EO Cubes that is being developed by a PhD student from INPE. This function, you can select you can select a part of a data cube, considering a period and a spatial region. So you can select it from a set of JSON files that describe the EO data cubes or the GeoT files that are stored in the S3 AWS in this case. So this is an example of the JSON files that describes what we have there in this case. Here we can see the GeoT files. You can get this, that are stored in the S3 AWS service. In this case, so we classified the Mato Grosso state in Brazil in 1.5 days, and we classify all Cerrado biome in Brazil in 3.5 days using the Amazon EC2 instance with 32 CPUs, as you can see here in this image. So this machine costs $100 per day, running 24 hours a day. So we pay this to classify all the Mato Grosso state and per day to classify Mato Grosso state and the Cerrado biome in Brazil, using modes product with 250 meters of resolution and they classify 17 years from 2001 to 2017. So now as I said, now this year we will start another project to build the Brazilian Earth Observation Data Cube. This project has two main goals. The first one is to produce data cubes of analysis raw data from medium resolution remote sensing images for all Brazilian region. We will use Landsat 8, Cibers 4, and Sentinel 2A and 2B. And the second goal of this project is continue to improve methods to extract land use and land cover change information from these data cubes, using satellite image time series analysis, machine learning, and image processing procedures. The data volume of the Brazilian data cube is around 600 terabytes using these satellites and this period that can see here in this imaging. And we submitted a proposal in the context of this project, the Brazilian Earth Observation Data Cube project. We submitted a proposal for the GEO AWS Cloud Credit Program 3 weeks ago to evaluate the AWS to build our data cube there. So in this proposal, we selected 3 study areas in Cerrado biome. And we will produce around 70 terabytes of data in these areas. And in this proposal, we intend to evaluate a lot of things. We want to evaluate the AWS Lambda service to classify time series without managed service, and the AWS SageMaker service to build, train, and deploy machine learning models. I didn't put here, but we put a task to evaluate the Open Data Cube 2 in the AWS, assessing these data sets. And thank you for the attention.
Okay, thank you very much, Karini. Now we have some questions. I would say that because of perhaps the interest of the GEO community, most of the questions are for the Knowledge Hub, and we have about half an hour. So I'm going to ask some questions from here and then open the floor as well. So for Miko is asking, would the Knowledge Hub also try to foster an EO developer community? Success on the web is through commitment of users, concretely EO service developers.
Okay, I will try to respond to that one. Since we're in the beginning of the initial stages of development of these ideas around the Knowledge Hub, I think this feature can be built in the longer term. It's not our initial, let's say, requirement, but it's definitely a possibility in the future. I believe there are already platforms out there that serve as digital repositories for this kind of solutions, but they can be integrated in the future. Why not?
I have another question from Anonymous. So that's the guy with that mask that appears on the web. A number of so-called knowledge hubs are already present. What is the added value of this?
I go? Yes, please. Let me try to answer this to Anonymous. Would be good to always know who's asking the question. I personally believe that the GEO is a unique organization and is made of a unique community of scientific contributors and researchers. And at the moment, GEO has an amazing infrastructure, which is the GEOS platform, which convey the effort of, we heard, 7,000 data providers or more. Now, there is a missing element, which definitely is the knowledge hub, and starting with the GEO community knowledge, that for which we are all responsible, the flagship initiative. So the added value that it is quite clear is surely to bring this wealth of knowledge that GEO is producing within the work program every year in the past and will be producing in the future. The added value is really to serve this out in a very smooth manner for the users now and for the future. For it's an investment to convey all this effort in an harmonized manner. Probably my colleague wants to add something else.
I have now not anonymous from Edza Pebesma. Will there be an editorial board that will do or organize a review of candidate Knowledge Hub assets and decides when something is ready for publication?
Okay, again, I will try to. It's as if the questions are very pertinent, but it's as if the Knowledge Hub already exists, which is not the case, right? We're in the initial stages of building the Knowledge Hub, so I cannot look in the future. But what I can tell you is that indeed the curation process is essential, as you have seen from the presentation. But we believe that the involvement of the GEO community is primordial, we have to do this, is essential. And we should also in the future look at all the new technologies that are out there. So the curation process for the moment is heavy, is manual. It will be federated in the long term to the experts in their different fields. But we don't, of course, we shouldn't exclude these new technologies, like natural language processing, like machine learning, to be integrated in the curation process and to make the curation process more intelligent over time, so that the manual part becomes smaller and the machine part becomes bigger.
Okay, thank you. I would now open the floor and exchange. Yes, please. Identify yourself, please.
I'm Peter from Ghana. My question goes to Karen. I wanted to find out from you why you use R instead of MATLAB. Any experience? That is the first question. And in terms of the machine learning, which of the algorithm did you find to be more efficient in terms of classification?
We are using R instead of MATLAB, your question, because R is an open source. You can extend it easily, and we are built the seeds R package using R and using the other package that are available there. So it's a very nice environment to produce this kind of package. Okay, the second question?
Yeah, the second question. In terms of the algorithms, the machine learning algorithms, which one do you find very efficient in terms of the classification, like the results?
In terms of efficient?
Yeah, like...
No, we are using R in the cloud, in the AWS. So you can, in this case, you can build the classifier in parallel because you can classify time series using parallel computing. So in this case, it's acceptable. It's okay for us to use it.
And
Can I just add 2 points? Because I did the parallel code. Okay. Before I came to GEO. This is one of the things that the whole community has to understand. If you have small amounts of data, you have big data, but your data cube is small, then everything falls nicely into main memory. Now, it is not a given that if you have a region to classify, which is the size of Europe, or almost the size of Europe, which is the Brazilian Cerrado, that you don't have to yourself to make sure that you have an efficient parallel machine. You cannot just rely on things. About the R versus Python, I mean, this is a choice of religion, but let me just say there is one thing about R which Python doesn't have. It's an organized community which people know and trust each other. So I know who wrote the R spatial package for R, and this guy is sitting on this room here thinking about and smiling, but I know the guy. So and he responds if I have a problem. And this is concept of trust in the community has been built in R for the start, which makes you much more confident that if you need support from someone, it's given. So we understand Python perhaps is more for easier for developers, but R is a community effort which has been millions of hours of real committed developers with a real good understanding of data analysis.
Okay, my last question. In terms of imaging, like satellite images, sometimes they have noise, like the images are not clear in terms of resolution, and we are aware that when you have such images, it makes classification and analysis very, very difficult. So how do you improve upon your images? Like when you have satellite images that you want to classify and these images are more or less corrupt or they contain noise?
In this case, in this case that I showed today, we use modes, so modes products. So now we will start to use the Landsat and Sentinel, and we have to produce these R data before classifying these. So in this case, we use modes.
Okay, but I think this is bilateral discussion. We'll be happy to address it later. Just get from the floor, Jean.
Thank you, Gilberto. My name is Jean Meto from Brazil. The first question goes to Pedro in terms of the hazard hub, GeoHazard. My question is that if there's a plan or if there's a thought associated to connect this data set, which seems quite impressive, to climate service, potentially have some sort of a hazard alerts. I don't know if there's something associated to that. And to Karini, the question is how the e-sensing is being validated. If you look to it's only if you kind of match that with the Terra class data or to other land cover data to validate the information. Thank you very much.
So, yep. The GeoHazard step is really driven by the users that bring their own problems and the users. For the moment, we don't have that connection to climate. We have another, we are also participating to another tab called the hydro tab, hydrology tab, where there we have a connection to hydrological modeling, to climate data and so on. In the GeoHazards, for the moment, there is no specific, but it's open. It's completely open. It depends. We have a process where a user appears with an idea of a project, and we move forward in that point. And with the the APIs that we have currently to access that type of data, it could be really quite straightforward. to deploy such a services and make it as a systematic point there. So you feel free to discuss this afterwards. Okay.
Okay. I will ask Gilberto to help me with this answer too. But we are using, in that methodology, we are using some masks. So we are using prods and some masks to these projects that you mentioned. And we are working on validating these land use and cover maps that we are producing.
Okay, I'm happy to take this question offline with you later, on the interest of having more questions from the floor. Any other questions from the floor? No, I'm trying to get, there's questions here. Some of the questions I just want to try to explain, and I try just to simplify things. There are a lot of questions taking that the Knowledge Hub is about data. So I think from the benefit of saving some time, and I just want to say, the Knowledge Hub is not primarily about data. It's about knowledge produced in papers and reproducible knowledge. So data as a bulk of the data, that is the role of the GEOS platform. The Knowledge Hub is only worried about data insofar as the data is used inside a method in a paper to generate a scientific result, not as data as such as a bulk offered to the community. So I'm trying to answer some of the questions here. Piotr has asked a question, perhaps I would like you to, it was not clear to me. Knowledge Hub with hosted tests can be a big black bag even with curated relations. Any automated semi-decomposition and classification or NILU is considered. I don't know, Piotr, could you identify yourself and explain it better? So I couldn't.
I think that the question was answered partly. So you mentioned that some automation will be introduced. This is partly connected with the second question about the community involvement and the processes. How will be this organized, and what will be the engagement fostering of the community, of the experts, and will be there any systematic way of organizing this? As I understand, the composition and the classification of the text, which is maybe not the core interest of this group, but this is something that currently is, well, highly developed, and this is something that is also part of the artificial intelligence that can help with the mapping of this text to the resources, to the data, to the keywords, and this kind of things.
Piotr, I think you answered a question that our team is not expecting. Perhaps we should discuss offline. Apologies for that. I think, I can say on behalf of the general story that the text mining that we have envisaged in the Knowledge Hub is based on the facilities that are available on the text mining abilities of things like Elasticsearch. So what you have now is Elasticsearch is the best open source tool for text query searching. It's used in many applications. But of course, what you're asking is some capability which is really advanced, and we like to discuss it later. Marie-Françoise Vaudreau has asked the question, is the Knowledge Hub only for research or also for operational use?
What do you define operational use?
Well, I have a very operational background with the French Weather Service, and I know that each time you want to take a decision based on a product, you really need to understand how this product has been built. So, which means type of information looking like the knowledge which is attached to research, but it can be more about an operational description on how the product can be used. It can also be some research documentation about the algorithm, how it has been developed and so on, and the limits of use of the product.
Well, I would say definitely for both. Operational is indeed one of the elements. It's important is the impact of all this knowledge for the end users and going forward.
Okay, now I have a question which is also for both Paola and Rick and also for Ivan as well. They're asking, the question here is from Anonymous, who says, what is the role for commercials? I imagine commercial companies, private commercial service providers in the GEOs, in the GEOs you envision. So that includes, I suppose, GEOs Evolve, GEOs Platform, GEOs Knowledge Hub. So what's the role of commercial sector?
Well, maybe I can start by saying that there's a new category in GEO that has been approved by ExCom, which is the GEO Associates category, which actually invites commercial sector entities to join GEO. So automatically they become part of the GEO work program, and make no mistake, they are already part of the work program since many years, but now they will be officially recognized. So their involvement is natural because we're going to involve the GEO community from the GEO flagships and the initiatives where those commercial sector entities are already included. So the discussion, the dialogue will be not only with scientists and experts, and it will also be with the private sector.
I add a couple of components here. The example I showed before on this publication related to hydrological modeling shows that within this publication there were mention about ESRI tools for the rapid hydrological modeling. Now, from private sector, just to mention one as was the example I had under my eyes, there is modeling and tools that in this case were open source and accessible in GitHub. So for sure there is an element for contribution to the Knowledge Hub. For what concerns the GEOS platform, there is already a lot of interactions of the private sector within the GEOS platform, both from the bigger and smaller commercial entities. So yeah, thank you.
Ivan, any thoughts?
I would just add that we hear this question a lot, and my response would be there's a number of indirect and direct working relationship with commercial sector within GEO and GEOS. There are a number of members and countries who, in fact, use commercial enterprises to support their work. In addition, as Rick has said, we now have a mechanism through the associate mechanism that allows commercial sector to participate. So it's almost impossible, at least in my viewpoint, in this space, to not have some level of private sector commercial involvement because of that growing enterprise and the need that we have in terms of meeting our requirements.
There is a question, I think, also for both Ivan and Paola and Rick. And it's about the comparison between what the GEOS ecosystem with Stack, Google Dataset Search, and OpenEO. Of course, people by 6 o'clock are sort of, the minds are floating around with acronyms. And I hope that you can answer. Ivan, any points? And then Paola, any points? Okay, so the question was, he mentioned, the person anonymous said, what about, how do you compare your work you're talking about with Stack, Google Dataset Search, and OpenEO? I mean, it's not an easy question to ask, so please do your best.
It's not an easy question, it's not an easy answer either, but I think there's something that we're looking at. As I shared yesterday, we're trying to improve the search capability of the GEOS platform. I think as we look at these standards that are being proliferated, we need to make sure that as we think about the architecture, that they are meeting the requirements of the community. So I think it's an ongoing process, and we're learning as we sort of go along with this as well.
So I don't have a straightforward answer, but I have an interesting story to mention about that. Last year, it was last year or 2 years ago, during one of the data providers workshop, Google was there, and one of the questions was, what is the difference between the GEOS platform and Google? That's a pertinent question, but try to type in Google now, dataset search is a different thing, but St. Vincent and the Grenadines, and the first items you get, or whatever location, the first item you get is travel to, booking.com, the best hotels within that location. Now try to type a location within the GEOS platform. All you get is all available data sets, Earth observation data sets, within open, ideally, within that location. Of course, we cannot compete with Google, neither is the scope. The GEO is a unique community pushing for open Earth observation. But of course, the two elements are, I would say, complementary, but dealing with different elements. Open EO, that's tomorrow answer.
No, just to help a little bit. Stack is a specification that describes a catalog. I don't think there's no comparison between GEOS, any GEOS platform and the Knowledge Hub. The Stack could be comparable, and then again, that was described here with the CSW, the catalog from OGC, and they are evolving together. But OpenEO is a completely ambitious, different, and very ambitious proposal, and very positive in the sense that it tries to unify APIs to access different cloud providers. So I would argue that there will be a time, hopefully, when software written in OpenEO will be deposited in the Knowledge Hub. So someone will write a paper, said, I did this experiment comparing the result I got in Google Earth Engine and in Amazon Web Services or in Creo Dias, and this is the OpenEO code who runs the example, and here you can yourself run this on Amazon or run this on Google Earth Engine, and you can compare the results. And maybe the results don't compare, or maybe they compare. So OpenEO is a important component of software that aims to break the interoperability barrier that currently exists between cloud providers. So as it hopefully will be a part of the community development of new results. Just to try and understand that today we covered a lot of ground, so I think we're probably very close to finish. So in behalf of everybody here, first of all, I would like to thank the speakers, because we had an extremely, and I am absolutely impressed, and I would like to thank everyone who spoke, who asked questions, because everything was spot on. Very good presentations, very sharp, and we had a very productive day. And incredibly, with all the presentations, with all the content, we could finish on time. So with that, I think I will leave you with a sign of relief that you can go home and have a nice beer or a nice Austrian wine, and see you tomorrow. Thank you.